In this video, we're going to discuss empirical formulas, including doing two sample exercises that ask us to calculate empirical formulas. So if you recall, in a previous video, I mentioned that an empirical formula is the lowest whole number ratio of one type of atom to another. So say we have hydrogen peroxide, which is H2O2. The empirical formula would just be one hydrogen to one oxygen because it's a one-to-one ratio when we simplify the 2-to-2 ratio. So our empirical formula would look like this. So if we're given some information such as the mass percent of elements in a compound, we can assume that we have 100 grams of sample. So in this first example here, we're given 87.5% nitrogen in this compound and then 12.5% hydrogen. So if we added them together, we would see that the two percentages equal 100%. So we can just assume that we have 100 grams, and then that gives us the grams of each element in a 100-gram sample. And then if we divide by the molar mass, we can find the moles of each element. We can calculate a mole ratio of one element to another. And then that gives us the empirical formula, like so up here, which is a molar ratio of originally 2-to-2 moles of hydrogen and oxygen, but then we simplified that to 1-to-1. So let's see if we can do that first here in sample exercise 11. And we're going to use that technique above. So we said that 87.5% we'll assume would be 87.5 grams out of 100. And that was for nitrogen. And then the other 12.5%, that's going to be hydrogen. So that's 12.5 grams out of 100. So we said that next we're going to divide by the molar mass for these compounds. So divide by 1.01 grams per mole, and that'll give us how many moles of hydrogen. And then if we divide by 14.01 grams per mole here, that will give us the moles of nitrogen. So this turns out to be about 6.25 moles, and this is about 12.37 moles. So what we can see here is now if we divide by the lowest number of moles, so by 6.25 here, and then by 6.25 here, we're going to get that molar ratio where we have 1 mole of nitrogen for every 2 moles of hydrogen. So that would look like this as the empirical formula, NH2. So we can do something similar if we're given multiple mass percent. So let's look at this question here, sample exercise 12, where we're given the compound para-amino benzoic acid, abbreviated to PABA here, which may be in a bottle of sunscreen because it is a UV protectant. And this material, PABA, is 61.31% carbon. So we'll just say that's 61.31 grams of carbon. Then we have 5.14%, so 5.14 grams of hydrogen, 10.21%, so 10.21 grams nitrogen, and then the remaining percent, 23.33, that is going to be oxygen. So let's find the empirical formula. So the first step, just like above, we're going to divide by the molar mass for each of these. So I'm just going to fill these in. So we have 12.01 for carbon. We have 1.01 for hydrogen. We have 14.01 for nitrogen, and then 16 grams per mole for oxygen. So let's divide by these values. And that gives me about 5.105 moles of carbon. Now we have 5.09 moles of hydrogen. 10.21 grams divided by 14 gives me less than 1 mole, so just 0.7 7.288, and I'll keep some safety digits here, moles of nitrogen, and then last I have 1.456 moles of oxygen. So now the rule is to divide by the lowest amount of moles, so that would be the moles of nitrogen. So for all of these values, we're going to divide now by 0.7288, and that will bring me my molar ratio, which I'll write at the end here. And since we're dividing 0.7288 by itself, that will give me 1 mole of nitrogen in this ratio. And then when we divide 5.105 by 0.7, I get 7 moles of carbon. Almost exactly the same number, so 7 moles of hydrogen. We had that 1 mole of nitrogen, and then 1.456 divided by 0.7 gives me 2 moles of oxygen. So now I'm going to arrange these in order of electronegativity. So I'm going to have C7, H7, N, and O here, and O2. So this is the empirical formula for PAVA.